Welcome everybody. This is finally a conductor a meetup with Netflix and Orkes together. We've been doing this for a while, and after a long break, we decided to do this again. Our first event for 2023. I'm proud to have some of the great panelists here. I have Joseph Karp, who's going to be presenting today. He's also a DevOps architect at United Wholesale Mortgage, and I also have Viren here, who's the co-founder and CTO at Orkes. Joseph will also walk us through a very interesting use case for Conductor, and I'd let him kind of take away and discuss how he's been using Conductor, what other applications he's been taking up. Joseph, over to you. I believe you can share your screen if you have any kind of questions. And right after Joseph's presentation, I think we'll have 30 minutes for Q&A. In the meantime, if you have any kind of questions for Joseph, please free to send them out through our Q&A section that's available for anybody to type in the questions. We'll be able to take these either by, in writing, or we can answer these live. So feel free to do that. Good to have you, Viren, as well. And we have Anoop, who is also a senior software engineer at Netflix. Ju, who is the CEO and co-founder at Orkes. And I'm Cherish. I'm a developer relations engineer at Orkes. And Joseph, over to you. Looking forward to listening to you.
Thank you. Just give me 1 second to share the screen. There, let's just hit play over here. All right, so the use case I really want to talk about today is something that's really helped me at the company I'm currently at, and probably would have helped a couple companies ago as well. It's more on the infrastructure side than it really is on the developer side, but this applies. You could apply it to many things, but we're automating application bootstrapping. So just a quick introduction. I'm Joseph Karp. I'm the DevOps architect at UWM. There's my email if you have any questions for later on and it elapses, feel free to reach out. I'll try to answer them in a timely manner. But with that, let's get into it. So I just want to build up some quick context and background, how we got to this solution, what we were trying to do and trying to solve, because I think that's important. So first thing is some weird mix-ups, and then we'll talk about the problem. So what is a DevOps architect / engineer? Well, at my company, and a lot of large companies around the Midwest, a lot of IT terms are misconstrued. They're not actually what it is. Like DevOps is a culture. It's not a person or a team or a thing. What the closest thing you could relate me to is a platform engineer or architect. I have a software background, and I have a software engineering background. I help out our architecture teams with infrastructure and building out services to basically aid in the development. And then what do I mean by application? Because that's a very vague term. I mean a deployable unit. So i.e. a microservice, a desktop app, a Lambda function, Azure Functions. So a thing that a traditional development team would be working on and deploying. And that takes us to our problem. So the problem at UWM really that we had is and this happens in a lot of large companies, is you have all these different siloed teams trying to build this thing, trying to get a deployment process set up and get that CI/CD from end to end working, and it just takes so long, 2 to 3 months. And there's a lot of pain points, there's a lot of mix-ups. We have to go back and fix things because somebody said something wrong, or somebody set something wrong in the workflow or somewhere around there. And it's a slog, and it leads to teams starting to find interesting ways to get around making a new microservice. So they start making macro services because it's less painful to shove more stuff into a microservice than it is to stand up a new one. And this problem gets worse and worse as your company grows and gets bigger and bigger. You just have more people and more process that bogs this down, and then your developers want to move quickly and you want to help them move quickly, but the communication and the coordination of these teams becomes a large problem. So solutions that we looked at. So I evaluated a lot of solutions, and I spent a few months just going down rabbit holes, trying to find the best way to do things. And so I want to acknowledge these things here. These are all solutions that can work, but have problems and some major downsides. So like event driven, like I could have strung together some event driven stuff with like Kafka, Azure Service Message Bus, SQS, a number of different eventing services, and like try to strung that all together. But as I'll allude to later on when I kind of show you some stuff, it's like the failure scenarios and coordinating those things, especially when you have a lot of parallel things that can happen, is just you quick nightmare. Like it immediately falls apart, and like you're just like, what did what? Is this still working? Like what's happening? It's just very hard to see into it, and that's just a product and a downside of event-driven systems. Is like, yes, they're very fast, but their downside is like lack of visibility, and I can't really afford to have that when it comes to infrastructure, because that shit has to work for the developers. Like it just has to work. So the next thing we evaluated was like maybe Kubernetes jobs. Like we could spin up Kubernetes jobs. They would run like a little script to do their little part. We can coordinate with teams on what those scripts are. But it runs into the same kind of problems as event driven does. It's very hard to like keep track of their statuses, failures, and that kind of thing. One thing that we really tried to push for to like lower it down as we were building out our other solutions was more process, and trying to improve and just make that process better, cut out people that didn't need to be there, like try to optimize the manual processes and the scripts that the teams were using to stand up the infrastructure, like maybe trying to build out Terraform scripts for them, maybe try to use something like Crossplane, those kinds of technologies to really coordinate the effort of getting these deployable units out to production as quick as possible. Because we're always making new projects, we're always making new microservices, and it really comes down that the communication, like at some point you hit a maximum, and like you can't go any further than that. And we managed to get it down to about a month by improving the processes, but like we just couldn't get it any faster than that. And like when you're trying to move fast and you're trying to be agile, like it's really hard to tell a team that's working in 2-week sprints to be like, yeah, you can't do anything for a month because we can't spin you up your new service. Like you have to stick it somewhere else and then migrate it, or you have to do some kind of patch job to like then move it into a service ready. So it's like it leads to a lot of lag time, a lot of like same problems, just like they're trying to find other ways to put this functionality because they have stakeholders that they're trying to please, and we're trying to get them up and running as fast as possible. So the other thing we could do is build out a monolith that could work, and it does have some advantages, but like as you'll see as I go to the next page, a monolith really falls apart when we start talking about when we get into the conductor solution. Like this really worked for us because if you look at everything that's happening in that middle bit, if I gave a monolith the permission to do that, I've basically created one single point of failure for my security team, and they would just crucify me on a like back there, just like, oh my God, like if that service account ever gets compromised, or if any of the permissions for this thing ever get compromised, or the container that runs it ever gets compromised, like they own the building. Like they could turn off my lights if they wanted to, because there's just so much permissions built into it. And this is a very simplified diagram of what our workflow for standing up an application looks like. And you can see we notify the user that, hey, it's begun. We set up certs and DNS. We create their repo with a known good app inside of it so that it immediately can start going up the deployment pipeline, testing, and deploy to production successfully. So we make sure everything's good on their deployment pipeline. We set up their secrets engine, so things like Vault or Azure Key Store or anything like that, so that like they have a place to start putting their secrets and start loading that stuff in so that they can get off the ground and running. And then we configure their deployment pipeline. So like deployment targets, like you need to be deploying to Azure, or you need to be deploying to GCP, or you need to be deploying to an on-prem cluster. They get to select that stuff, and we have a worker in the workflow that actually sorts out how to set up those environments, how to configure the deployment pipeline so that they're ready to go. And then the ending bits is it also notifies the user that like, hey, you're good to go, everything happens. And again, like if we had teams doing these, the coordination between all these different groups. Like if I change something about the DNS, that affects how I set up the repo, because like we have some values in there and it's got to be aware of like a couple things. If I change the secrets engine, that also affects the repo. Like where are my secrets? Where do I go to grab them? Same thing with deployment pipeline. Like, am I deploying to Azure or GCP? Like if you change the certs and DNS on me and what that looks like, I need to redeploy those somewhere else, that kind of stuff. So a lot of miscommunication usually happens between these things. And with Conductor, what we did is we basically went to each one of these teams and been like, what's your process? We took that process, we put it into a tiny little microservice, and that allowed us to iterate pretty quickly and get the solution off the ground and up and running super fast. It took us 3 months to get the initial just MVP out the door with a couple of these, and then we keep adding on to it, and we keep having that nice agility, because like the people who own the communications, like the ability to send out emails and stuff, is different than the team that can make certs and DNS, is different than the team that can actually create repos inside our source control, is different than the team that manages our secrets engines, is different than the team that actually sets up the deployment pipeline. So you have 5 to 6 teams trying to coordinate, and we basically went to each one of them. We built out a service that they approved of, and we went over how it functions, and we were able to test that unit of work, and we put it into this workflow, and that basically got us down to 2 to 3 minutes to set up a new application from nothing, ready to go to production. Like in 2 to 3 minutes, you can go, I'm going to fill out this little form of all these little things that I need to do, hit enter, and 2 to 3 minutes later, I could be in my repo coding, pushing out changes to production, and like just off and running. Like I don't have to care. That alleviates so many problems in our stack, like with people trying to just like turn microservices into macro services because they don't want to wait for 2 to 3 months to get a new microservice stood up. And this really works for larger corporations, especially out where I am. Like if you go to GM or Ford or any of these guys that are like, they're not traditional software companies, their tech stack is not cloud native. Like interacting with the various different bits, because you're dealing with like AD domain controllers, you're dealing with like all different kinds of tech stacks that the infrastructure teams are using to manage like certs or manage DNS or manage repos. Like, are you using Bitbucket? Are you using like GitHub? Are you which provider are you using? You're not going to have cloud native solutions for some of these larger companies, and making these small little microservices to perform tasks in those systems and be like that nice go between and create that interface for us to basically build out these workflows is super empowering, because we can keep adding on features from here, because we did not end there. Like we did not, like we kept going. So like once we got the bootstrapping, like now you can create a microservice in 2 to 3 minutes. Well, they did exactly what you thought they would do. They pumped a ton of them out. They're like, I want more, kept doing that. So we made a decom process. So like maybe they wanted to change it. Maybe they wanted to do some other things. So we made a full teardown process. So 2 to 3 minutes, you can tear down the thing you just built up, which is super nice because they can test things out. They can try ideas. They can get what it will look like and start working on those ideas, and not fear that like, oh God, like we built all this infrastructure out and now it's stuck there and it's going to take a whole decom process. It's like, nope, we just went back to those teams. It's like, how do you do decom? We built out the task for that. This also started enabling us, once we had the decom, is now we could decom part of the infrastructure and migrate and move applications over to different places. So say it's cheaper to run in GCP for this particular workload than it is in Azure. I can decom the production infrastructure over in Azure and instantiate some over in GCP, and then deploy the app out that way and modify the bits in between. We can do patches. So like certs expire every year. And if you're not using something like Cert Manager, not many of us have the luxury of being able to do that kind of stuff and be fully cloud native. It's really nice to have a process to interact with the system that actually provisions the certs and you don't have cert apocalypse day like we used to have like 2 years ago, where, oh yeah, it's that time of the year, all the certs are going to expire, hope we got them all. So it's really nice to be able to build that in and then make a worker and then schedule that worker to keep the certs up to date and basically give you that functionality that cert manager would normally give you inside a Kubernetes cluster, but give it to you in a more generalized fashion so that you can reuse it in many different places, because we not only have Kubernetes apps, we also have traditional VM deployed microservices on that infrastructure. So like we have to keep on top of that stuff. And then testing is like, if you have a decom process and you have a build up process, like if you have create destroy, they technically should undo each other. So you can make a property based test for yourself inside your workflow. So you like how we test a lot of our stuff is like, okay, build it out, wait a set amount of time, and then tear it down. And if that test, like the little verification step at the end, just make sure it was built up and tore down successfully, like it's good to go. Like it opens the door to test a lot of the things and clean up our tests really nicely. So we've started a practice of, for every create thing that we do, if we can do an equivalent destroy and then make a workflow to basically validate that we can always create and destroy on demand as we need to, it really helps with the testing and helps accelerate our process. And what really enables this is like the composable nature of Conductor. When you make tasks, you're basically just making little pieces of work that you can just join together and glue together and make bigger and bigger things. And it's really helped us over the past year, just getting off the ground and really accelerating this process. And our development teams love it because they just make it real quick. It happens. They don't have to worry about it. If there's any failures, we can handle all the failure scenarios. It's very easy to see, very visible to the end user. And we can compose more things inside, and we can add more bits as we grow. Like we're planning to add in SSO setup eventually to generate key like client IDs and secrets and like that kind of stuff. Make a step that does that. Like it's just so extensible and composable that it really, like anything at this point that our development teams need to automate, we can just automate by spending a little bit of time putting up a new little worker to do that task, and then just incorporating it into the overall workflow. It's very empowering. It's like I can't tell you how much like time is saved just by doing this. And then when we have problems, I can isolate it very easily to that one task. Like, oh yeah, certs and DNS exploded. So the cert job exploded. So I'm going to go look at that service. Well, the system that's using that is currently underwater. So it's like we built a retry around it because like it could take up to 45 minutes for DNS to sync or to propagate across our network. It can, so like we made a little loop to check every couple minutes to make sure like, did the DNS actually commit to the domain controller and did it propagate across all of our environments properly. So we can put in checks like that without having to do a whole bunch of extra coding. Like we can also do optional steps like with the ifs inside of the workflow and that kind of stuff. So it saved us quite a bit of time. And it's just a game changer for us as a whole. And we're starting to, because the development teams have seen us use it, we're starting to implement it into our business processes as well, because it's just so handy. But that's basically what I got for you today. Just a quick talk about it. So I'll be happy to answer any questions that you guys have. I know I talked pretty quickly, so I probably got through that super fast. So
thanks, Joseph. No, I think this was extremely great, extremely beneficial. I like especially the Daydown approach. I think that's something that's new for me. Also cool to see that you brought down the time to 2 to 3 minutes. I think that's fascinating in its own right.
Yeah, because we could parallelize a lot of the processes. Like the big problem is like when you had these individual teams and you have like, I don't know if you guys have ever used ServiceNow, you have this workflow in ServiceNow, and ServiceNow doesn't really do good with like parallelizing it. And then each team has priorities. They're doing their own stuff. So like you get they have other work that they have to be doing, and then suddenly create this new application comes in, and then you have to wait for you to get through the queue, and then they hit it, and then they do it. So it really cuts down a lot of the time, because a lot of these teams had scripted out what they were doing. Like they have processes for it, but you have to wait for the team to have resources. You have to wait for the team to actually begin work on it. And then you also have to account for miscommunications between teams. Like they can just stumble over each other. Like that communication barrier is really a big thing that caused it to spin out to 2 to 3 months, because like, oh, the server team didn't configure the VM correctly, like it's missing these certs here, or it was expecting a different cert because the architect decided he wanted to change the name. So like it really helps to shorten that process. And we've had a couple architects name services wrong. They're like, I don't like this name. So we have the ability called a soft delete now, where it'll delete everything but the repo. And then you can rescaffold it with the new name, and it'll keep the repo and the secrets engine and just kind of like move them over for you. And that also saves a lot of time, because everyone's bad at naming things. Like that's just part of the territory of being a developer. You really so like when we need to rename things, or like the business even, like I don't want the URL to be that. I want it to be something else. It's now a simple change. Like we don't have to jump through hoops. The architect or the development team can go into the service with the correct permissions and just type it in real quick, hit enter, and it just provisions it and it goes out. We do plan later on to make it a more of an IAC approach, and actually make some YAML definitions for what we call Keystone. And so you can lay out your entire application's spec in a YAML file, and then when that changes, we'll use Orkes's scheduler to basically scan that repo and just detect the changes, run the updates, and then output the status. Basically turning it into a Kubernetes operator, essentially, which is super useful.
This is great. Awesome. I mean, like, kind of, it's a great segue also to kind of the questions that we've received. So I think we have a bunch of questions. I'll just throw them your way and you can answer these live.
Yep.
Give me a second. I think so. The first question that we have is, so compared to the solutions that you've done before, how has Conductor and Orkes helped in terms of, in which areas?
So compared to like, I'm more like, I've interacted with a lot of event-based systems, and was like a large trend for the past couple of years, is like make everything event-based. But the big problem is visibility. And really, like there's two major things. So visibility is one, error handling is another. And those two do not work well when you're trying to parallelize things. So you just get this huge sprawl of like, well, what happens if DNS and certs fails, but repo's fine? This is fine over here. The service at the end that basically says everything's complete has to like maintain state now. Like you now have to like explicitly make that service wait for everything to finish. And does he just hang forever waiting for that certs and DNS to finish? And then I have to build in observability tools. So I have to make Splunk dashboards or Datadog dashboards monitoring these queues. And when something goes wrong, I have to either build it into the service itself to basically retry a couple times and then call out for help in some way. So now I need another topic and another queue to like basically call out for help, or I have to set up all these dashboards and things. So like it saves a lot of time, because that's what Conductor does, is like it manages that business flow and helps me retry those workflows, see what's going on, and it makes my services so much more lightweight. They don't have all this business flow built into them. And really that, while you are coupled to the orchestrator, you're now decoupling the services from themselves. Because what I see a lot of our services, like on the business side of the house, have happen is the service becomes bloated with all this extra logic inside of it of how the flow has to work, because they're choreographed. You're just so coupled to that flow that if you deviate from that, you can have some major side effects, and it just knocks on all the way through the system. And there's not a really good way to see those knock-on effects like easily or quickly. You have to put in a lot of tooling in place. So this was very easy to just stand up, get working. like we even automated all the permissions. So like when a developer says like all I have to do is like inside their repo, they just have an IAC folder. They put in their values that say like, yeah, I'm a worker for this task. When it deploys, it just grants it that, puts it into the key store for them, and then they're off and running. Like something with Kafka and like those other systems, you have to do a lot of hoop jumping to make sure everything's secure. Only the right services are actually publishing and talking to it. And then you have all that business flow that you just end up coupled to, that really bogs down your system and eventually just causes it to come to a screaming halt.
Yeah, makes sense. You're right about like the cascading effect of choreography. I think, and needless to say, if there's even like a minute, the minutest of changes, God only knows what that can turn
Yeah.
into.
Yeah. And not to say choreography is bad or anything. Like if you need raw speed and performance, like you can go choreography. Like that's what Kafka is for. Kafka is really fast at data processing, but it wants something in and immediately out. Like it's not meant to coordinate this whole thing. Like you're trying to strap on something to Kafka that it's really not meant to do. It's meant to take in data, get it out, transform it, and move it on to the next thing. It's not meant to be this business flow type of thing. So if you have a whole bunch of like IoT devices sending data and you're collecting data and dumping it into a data lake, it's perfectly good for something like that. It's perfectly good. But for most things that like I do, especially at a mortgage company, where there's these long flows of things that have to happen in a specific order, or like several things may happen and then they have to come back together, Kafka's not going to really help you out because you have to put all that into your services, and then you get overwhelmed with error cases. Like, oh, I didn't think of, because like this one fired over here and that one fired over here, but they're not really together. Like really this needed to happen first, but that needs like, then you have to figure out how to arrange them, and you just end up pulling your hair out.
Yeah, I completely get it. I think, and you kind of touched base on the next question, Joseph. I think, but I'll just ask it again. So somebody asked that, what was your effort level need to use the conductor for this case? Did you have to re-architect everything? Was it relatively easy to bring in conductor to this solution as compared to writing something by yourself?
So initially, before we brought in Orkes to like have that instance up there, I built out a whole Helm chart to actually deploy Conductor myself to Kubernetes. And that was a bit of an effort for me. It took me about like 2-3 weeks to build the images, get a Helm chart that would actually work, and deploy it, and get Postgres and Elasticsearch working together with the main Conductor server and the UI running. So I basically took what was open source and I tried to build it myself. And that was really hard to maintain initially, but it worked really well. It was just kind of missing that security layer that I really wanted, because I was starting to use Istio to basically do all the security for that, and that got a little bit over tentative. So I like the product that Orkes has built, and we've started using it, and it just makes everything so much easier. But if you can get an instance running somewhere, once you get the instance running, it becomes super easy to convert things over, because your Kafka workers or pullers work the same way as a Conductor task. So if you're, at least on the consumer side, because it's doing the same thing, it reaches out, sees if there's any task there, and then pulls it down, does the work, and then reports back. Where instead of having that out of publishing the topic out somewhere, that's the only kind of difference, but you already have that loop of pulling for something in your application. So it wasn't too hard to convert some services over to just being a worker versus just a consumer on like an event-driven platform. And like I said, once we got Conductor up and running, it was like a breeze. Like it just, like I could make little services, is like just immediately attached them. I could test things independently. I can have my, like, I love the little Docker image to spin it up and be able to test locally. It just helps so much. Where choreography, like, oh yeah, this service has, like, if you try to stand up your own little Kafka with choreography, especially if a service that receives multiple things and outputs multiple things, it becomes like hair pulling again, because you're just like, oh, I got to set up this Kafka cluster every time I start my app to like receive all the events, and then I have to play little operator here and just like push all the buttons to hit all the events to get into the service and then see what their outputs are. And like you're playing investigator on your local Kafka cluster, because it really doesn't come with a nice UI or anything like that.
Got it. Makes sense. We have a lot of questions coming in. This is great. I think you're just stimulating a lot of minds right now. This is great.
Yeah.
I somebody asks, can you share a sample workflow to visualize your deployment process? Is this something that's doable?
Yeah, I could. I would have to fetch it. I'm currently on my own personal PC at home right now. I have the day off. I took the day off for this.
No.
Yeah. But I could definitely try to get one in the chat when we transition over to the other guy. I'll see if I could dig through, and I have a couple pictures on my phone that I could get over here, but it is actually quite large. Like I built each service to be able to like do one very specific thing. Mm-hmm. And the team was really good at building services to do very specific things. And then we basically parallelized the whole thing. And the thing, like, it's very hard to fit on one screen. Actually, I could probably, give me a second. I can actually Karp at UWM.
I think another thing that I think we should probably do is we send a monthly newsletter to our community. We will attach, obviously, the session of that we're having, a recording of this, along with the sample workflow that he'll be sharing. I think I will take a note of that.
I'm pulling it up right now. I actually forgot that I could now access Conductor from anywhere.
Nice.
Yep. So let me just share my screen real quick.
Oh, great. Okay.
Yep. So we have the send email task. So that's its own worker. And then we have this giant fork. And I mean absolutely giant. But what you'll see for most of the things is you'll see so you'll see this thing called app-reg job task. This actually updates a UI that we have. So it actually reaches out to that service, tells it that like, hey, I'm going to go start this job. So like you could actually watch these things in real time on a UI for the developers and architects that are building it. And it'll actually show that like, hey, this job failed and that kind of stuff. So we have like it creates that job task to show on the UI. It then, so like here's that deployment pipeline task. And then we have an update the job task to say, hey, this completed, and they'll actually see on the UI, like turn green, like completed. And then you have all our different switches. So like if you're just building a UI, you just need a static web serve. You don't need secrets. So you don't have to do the vault setup. So it'll just skip that use case altogether. And then if you do, it'll actually go in here and it sets it up for each of our 3 environments. So we have integration, staging, and production. That's how our process flows from your development laptop all the way up. Things don't just go straight to production for compliance reasons. But you could see like we also fork here, and then there's workers and there's more tasks inside these workflows to do certain little bits like setting up permissions for the app, authenticating it to a Kubernetes cluster, and that kind of stuff, like building those trusts between where it's going to be deployed and the vault store. And then we also have this switch case over here. We basically go out to the Kubernetes cluster and it grabs their ingress controllers. It basically returns a set of IPs of where the ingress for each of the environments that they picked, and then filters that out to each one of the sub workflows to basically set up certs and DNS to that cluster. So it'll actually go onto the cluster, drop certs. It'll take the Istio egress or ingress gateway and make DNS to there. And then all that joins back together and goes back down. And then we also, here's the create repo part of it. So once again, updating the UI, creating the repo, updating the UI again, and then they all merge back down to here. where we update the UI once again to say the whole application has been stood up, and then we send an email out to the relevant party to basically say it's done. And then we've built all kinds of other workflows around this, and we reused a lot of the things that are in here to be able to migrate stuff. But this is this is our biggest one, our most complex workflow. The teardowns, much more simple because it's deleting is just like we just have a giant parallel. But yeah, that just gives you an overview of like what that creation workflow actually looks like.
This is great. Thanks.
I hope that helps you kind of visualize it.
Yeah, it did. Thanks for whipping it up so quickly. I wasn't expecting to be that that be so handy.
Yeah.
Awesome.
Yeah, and you could really see the complexity of like each one of those things is something that a team member had to do manually. Like there's so many steps in there, and like imagine any breakdown in that communication would really cause that whole process to fall apart.
Somebody asked if we could see the execution also. Right.
I don't think I can show that. I can show you the template, but I can't show you the actual execution because like there's company like stuff inside. So if there's like a secret project name and like that kind of stuff, I can't show you.
No worries.
I'm really sorry.
That's okay. Hey, somebody asked, was debugging easier with Conductor compared to what you have done before? Can you give an example of how that helped?
1000%. Like it is so much easier to debug with Conductor. Like I have proven that it has been an infrastructure issue faster with this, because what I could do is like, oh yeah, this was working. It received the same input. It should do the same output. So all I have to do is put that back in, and I can test like say certs is not working. Like for some reason it's erroring out. I'm getting like a weird error message. I can take something that I know worked before, like an input that I've done before, and because I built the services idempotent, they should work the same. So like building out like that test workflow where you create something and then tear it down immediately, I can just rerun one of those and I know it should work. So I could tell if it's the infrastructure actually broken. I run it and I was like, I know this was working. We haven't made any code changes to this service. Like I can go into the Git history, see the code changes. We haven't made any code changes. There's something wrong with the infrastructure here, or we lost permissions somehow. And it just saves so much time. Cause like before, like you'd have to basically get the logs of what's going on inside that unit, and then just basically toil on it for a couple while. And then like you don't always have access to like publish Kafka messages directly to the service to test it out. So like, and like locally, like I can run these things in production and test it out in production. And I have a way of doing that where like if you're running like a Kafka cluster, you normally don't want anybody futzing around in your Kafka cluster in production. Like you don't want people publishing like test messages and that kind of stuff, where I can like isolate bits and pieces here to test out and like have them go to non-production systems or supply values to test it out in a sandbox. To just speed up that process. And certs and DNS is usually the one that likes to fail a lot of the time, because like that, just the tool we use is kind of slow. And so it doesn't always respond well. So it's nice to have the retries in there. And like when we see certain errors, like they're visible immediately. We have a failure workflow that emails us with like what happened. Like we receive this email. It's like, that's so nice. Like in Kafka, I would have to build all that stuff out myself. I'd have to publish it to another topic. Like it's really hard to see what's going on in the different environments with like something like Kafka. It just saves so much time.
Yeah, I remember speaking to somebody who had similar alerts when something would fail. And because of a lot of things that would fail cascadingly, right, they would get alerts after alerts. But having a workflow like that could obviously help. One more question that's something I'm really interested in knowing is that any specific Conductor features that you would like to see enhancements of on, and conversely, anything that Conductor is missing which would have made your life easier during the development?
So features I would like. So it has worked really well for me. I guess. I mean, it's like a lot of my needs have been met with it because like I can develop locally with it. I can easily test against it. No problem. I know with Orkes, there's a couple things with like how tags and groups and stuff work. Some of those things, like I do wish were like a little bit better for like if a worker has execution rights on a workflow, it also needs execution rights on all the tasks underneath, which can be a little bit cumbersome to set up. But that's not like I have automated the permissions, so I just list out everything that's in the workflow in the permissions, and then when it deploys, it gets the permissions. So it hasn't really been that big of a headache. I would just like it. It really solves a lot of problems for me. I don't have like right now any features off the top of my head that I really need because I'm
Cool.
like
I get it.
yeah, it just works.
Nice. Yeah, that's good to know. Two more questions are in these final questions. One is that are you operating Conductor as an application where you maintain and control all the tasks slash workers, or as a platform where your users maintain and control workflow and tasks?
So what we've done is we set up, we call it the IAC project inside Bitbucket. And inside there, we have a Conductor metadata repo that actually houses all the JSON definitions of all the workflows and tasks. And any user can go into there and add their task definition and add their workflow definitions or update them. And then they follow a normal like promotion process of I'm going to PR it in, and then someone's got to approve it. And then once it's approved, there's an automated dashboard to basically promote those changes. So everything that we do with Conductor is managed through config as code. So a local user can basically go into that place, be able to grab the definitions that they need for their service, paste them into their local Conductor. That way they can just get off on the ground running super quickly. And then that's basically how we do that promotion is we treat it as config as code, and we are trying to move most things that way. Yeah.
Nice. This is great. I think a last question that's there. I think Viren's also answering this. But if someone wants to use Azure, step functions and Conductor, how do they go about it? And is there a way to integrate this? I think Viren, do you want to take that?
Yeah, sure. So short answer is yeah, that is doable. The slightly longer answer is that essentially the way it would work is, there isn't any kind of out of the box integration in the open source yet, but you could write a worker that essentially takes inputs as whatever input you want to give it to the function, and the name of the function and any other information, like for example, if it is an AWS step function, or sorry, AWS lambda function, then essentially it could be an ARN of the function or just the function name, and the worker can basically use the AWS SDK to make a call. And this way you can nicely integrate lambda functions into your Conductor workflows as pure serverless tasks. The other option is that we are actually on Orkes side releasing our or we actually have fully onboarded now on Azure. So you can leverage that to also kind of integrate with Azure Functions, which we are currently testing. So it should be available in GA pretty soon, where you should be able to configure a task, provide all the information, and it will automatically call the Azure function. Same with the AWS as well.
Yeah, I actually have an alternative solution. So if you just build like a normal microservice and just basically treat it as a function, just give it an API or put the little worker code into it, you can actually use the technology if it's deployed to a Kubernetes cluster called Takeda. And we've done this with our like email service and a couple other services, is they don't need to be running all the time. Is we pull, Takeda will pull Conductor to figure out what the queue size is, and we'll actually spin those workloads down to 0. And then basically when a workload executes, it'll go through, it'll show 1 in the queue, and Kata will now know how to go, hey, I need to actually spin up that worker. So if you want like an alternative to, instead of setting that up and you're already inside Kubernetes, I would definitely look into using something like Kata to spin down your workers or your Kafka consumers and producers down to 0 when they have nothing in their queue, which essentially gives you that functionality of a function, and gives you a little bit more versatility, because Lambda functions and that kind of stuff usually pins you down into a vendor. You get locked into that vendor, and if you build it into Kubernetes, if your company is using that, or if you have the ability to, you can use an operator like Kata to actually build out a policy that'll spin those down to 0 and basically act like functions.
Nice. Joseph, this is great. Thank you for answering every question. You've been extremely elaborate and explain things really well. I'm sure when I'm going to rewatch the recording, and a couple of people have already asked for the recording in their emails, so this is great. Thanks for taking out the time, Joseph. If you can hang around and answer any questions if they come along, thanks again for your time. With this, I'm going to pass it over to Viren, who's going to discuss some updates that are now on Orkes. Thank you, Viren.
You all can see my screen, right, Cherish?
Yes, we can see it.
All right, sounds good. So let's talk about. So what I'm going to do is I'm going to spend the next few minutes talking about some of the new exciting features that we have built in Orkes Conductor, and wherever possible, I'll kind of go through the live demo as well, so we can see how that operates. The very first one essentially is support for webhooks. This is an interesting one because oftentimes what you need to do is you need to be able to have a workflow that integrates with the third-party services. Think of it as like, you have a workflow where you are, with conductor workflows and HTTP tasks, you can always make an outbound connection, right? Like you can send a message to a Slack channel using the URL. You can, as Joseph mentioned, right? Like if exposed, you can also call into, functions like Lambda functions and all. But what happens when you have a workflow where you want a third-party service to give you a callback? Now you can always kind of create an API endpoint yourself, where and you can expose it to your kind of third-party integration services, and that API implementation can then call it to Conductor, right? So then that becomes pretty much like a boilerplate cookie cutter stuff that you need to do over and over again. And also then you have to handle other situations like, for example, when you integrate with things like, for example, Slack, right? How do you kind of provide a webhook to Slack? You need to kind of do the right integration. And unfortunately, when you think about the entire ecosystem of webhooks, there are standards and specs, but the reality is that pretty much every provider who can call your services as webhooks implements different ways of verification of their API calls. And the idea is that you get an incoming request. How do you ensure that that request is a valid request, is coming from a trusted source? As the very simple thing to do here is to kind of check for headers and verify that the header contains a known secret that you have passed and shared with them earlier. That's the simplest mechanism. But then there are more complex things that companies implement. So which is what we kind of tried addressing that with the webhooks. So let me show you how kind of that works. So I'll briefly jump back to the UI. So this is basically when you log on to Orkes Conductor, this is a playground which is available to everyone. You can go to webhooks, for example. I have a simple webhook here. So I've created a webhook. Let's try to create a new webhook here first. So, you give it a name, something that you can identify. Now, there are two ways you can use webhooks, right? One is that you have a workflow where somewhere along the line inside the workflow, it is waiting for a webhook event to come so it can proceed further. In that case, you can specify which workflow should receive that webhook event. So it kind of narrows down, you could have tens or hundreds of workflows defined in the system. This kind of narrows down to say only this workflow will receive the webhook event. Where is this webhook going to come? And this is mostly kind of to make it easy for you to kind of integrate, right? So take, for example, let's say if you are integrating with Twilio to give you a callback, the way Twilio works is that you specify authentication token to Twilio in your kind of Twilio developer settings. And then the same token you pass here. So, every time Twilio makes a call, it will have a header called x-Twilio signature. It will have the same authentication token. And then, system will verify that. For someone like Slack, as you can see, there isn't anything there, right? What happens with something like Slack is that when you do a create here, let's say when I create, system will generate a very unique URL that is specific to this webhook. The way Slack approaches the same situation is that you go to the Slack developer console, you put the URL, Slack sends you a test message that you acknowledge, and now the handshake is complete and URL is verified, which is why currently the URL is mentioned here as an unverified URL. And pretty much everybody has a different way of doing things. And the simplest thing here to do is kind of have something like custom verification mechanism. You can specify your custom header. So like I can say auth token, right? And I can specify some value. Now, every request that comes here should have a header called auth token, and it should have this value. Only then it will be matched. Otherwise, no, it will get rejected. So this kind of takes care of, ensuring that Conductor verifies the incoming webhooks. Now let's take a look at one of the webhooks. So I have a simple webhook here that I created with a token. And I created a workflow to test this. So I have a workflow here. So if I go to the workflow, test incoming. So this is a workflow here, right? What I've done here is that I have one task here. The task type is called wait for webhook. Like if I show you the code, this is the type of the task. And this is similar to a wait task. So, when a workflow starts, this task will basically wait. Now this task has kind of reference name as expected, right? And here is the interesting one. Imagine, let's say you have 1 million instances of running workflows here. When a webhook event comes, how do you correlate that event with the exactly one running task or one or more running tasks and complete them? So this is how kind of the matching works. In this case, what I am saying is that this workflow has an input field called recipient ID, and you could have multiple workflows running at a given point of time in the currently running state. When a webhook event comes, look for this information. Look for a field called data, which is a JSON map, extract another field called recipient ID and match that with my input here. And if that matches, this is the event, this is the task that should be marked as completed. So let's take a look at one of the executions here. So I have one that is currently running here, as you can see, right? It's currently in progress. It's been there in progress for a while. There's a simple site here that allows you to kind of send, call requests to sites. So what I'm going to do is that I'm going to just send a curl request. This is the token that we configured in the webhook configuration. Content type set to JSON. This is the webhook URL that is unique to this particular webhook. And as we said, right, I'm sending a data here, which is a JSON payload with data and recipient ID as 123. Now let's look at the input here for the workflow. Recipient ID is set to 123 here. And I'm going to send this and completed. And as you can see, right, this webhook is now completed. If I sent any other payload information here, it would have come in here. But this allows you to kind of integrate with third-party systems and make Conductor more kind of usable for things like, event-driven architecture and stuff like that. So this is about the webhook. Now, the second piece, when you think about integrations, is the secrets. Like I need to make an API call to a third-party service, and when I do an API call, I need to also pass in a security token. Now, I can always put that security token as a header or a payload inside the HTTP task, but then now this is visible to everyone, right? So that is a bit of a problem because anyone can search for it, anyone can take a look at it, and you are exposing your secret into the UI, it's searchable and whatever not, right? Your security folks are not probably going to like that. So what we did was we implemented secrets And secrets are just that, right? Like you can create a secret by name. Let's say Open API key, right? Let's say I'm trying to do something with Open API, and this is my key. I can edit here, and it becomes available. Now, how do I use the secret? When I want to use the secrets, basically, what I do is let's take a look at a simple example of a workflow, right? The way you do is that, like, just like, when you map the parameters, you can specify a workflow.input or task.output. You can also do workflow.secrets and the name of the secret. So now what will happen is that, the secrets are only resolved at runtime. They are not stored, which means that, like, when you run the workflow, the secret will be pulled from the secret repository and it will be used, but it will not be stored, archived, or anything. So, like, when you look at the workflow execution at runtime, the field will remain kind of unpopulated. So, it's only available at the runtime. It makes debugging a little bit harder, but it kind of gives you that level of protection. Now, where do their secrets get stored? Again, like, we implement secrets are very pluggable, and what we do in our cloud environment is that if you're running on AWS, we use SSM parameter store, which means you can manage your secrets outside of Conductor as well very easily, and be assured that, like, it follows the same security and guarantees that AWS provides. Same thing with Azure. It uses the parameter store, which has secure parameter store and GCP equivalent of that. So this way, like, your data is kind of stored. And if we ever deploy Orkes Conductor into on-prem, we can integrate with things like HashiCorp Vault or other kind of third-party secret storage as well, including just storing everything into memory for local testing and things like that. So that's another feature that is kind of does not really add a new feature or a functionality to workflow, but, like, helps you protect your kind of sensitive information. The other thing is that, like, we have done is that if you ever have like, for example, this is the example of the workflow, and as you can see, right, typically what happens is that when you have a payload that is a parameterized at the runtime, you can see its resolution and the actual value. But in case of secrets, you just see the parameter name. You don't see exactly what value was there. So if I want to see what was there, I can go to secrets, and if I have access, I can take a look at it. Now, since we are on the theme of kind of security, the other thing that we had implemented, and I think we showed this in the last meetup, was Orkes Conductor comes with a very robust security, including SSO integration for authentication and a very kind of fine-grained RBAC rule-based access control, which means you can create users, groups, even applications for programmatic access, and grant permissions to various groups and users. So, like, for example, if I have a finance group, I can specify which workflow they have access to, which is great. But it creates one more operational challenge in terms of, like, say, if you have a large number of workflows, every time a new workflow is created in the group, now you have to go back and add it here, right? And what happens if the workflow you no longer want to make it available in the group, and that becomes a bit challenging. Typical way to do things, like, that makes this process a little easier is through tagging. You can attach a tag, and you can grant permissions to a tag. So, like, for example, in this case, as you can see, right, this particular group has access to 2 specific workflows, 1 task and 1 tag, saying that anything that is tagged as org account, you should have read permission. Now, I don't have to worry about adding the workflows and tasks and secrets as specific things here. All I have to do is that I can go to workflow definition. For example, let's say I want to make this loan application workflow accessible to everybody in the finance group. I can say org account, and let's see, and the workflow is now tagged, and essentially I can anybody who is in that particular group will be able to see the create loan work. And tagging also applies to not just workflow, but also tasks. It also applies to secrets, which means that if you want to share secrets, you can apply that through that as well. So that's another exciting feature that we added that kind of makes the lives of people who are responsible for managing users and authorization in Conductor easy by tagging. We also have a way to do automatic tagging. So and this is for some of the kind of custom enterprise deployments where we can also do automatic tagging depending upon the URL that you come from or other properties of the system. It will automatically tag, which means you can create different API endpoints for Conductor, which in the end points to the same backend instance. But you could have accounting.orkesconductor.net, finance.orkesconductor.net, and then if you log on through finance, all the workflows will be tagged as finance and so forth. So that kind of also makes it fully operational in terms of doing automatic tagging. All right, and of course you can also search by tags. So you have a lot of workflows. I want to see which workflows are available for accounting and everything. So I can also do a search based on tags. So that's another feature that you should be able to kind of use. All right. So I will pause here. Happy to take any questions or if you want to kind of see anything else, we can definitely go over that as well.
Thanks, Viren. I think okay demos so far. Just one question that has come for you, which is, where can I use these? Where can I use these features, webhooks, tags, etc.? Is there a service available to use in Azure and GCP? Where can I find more info on this?
Yes, absolutely. So if you want to give it a shot or try it out, you can go to play.orkes.io. It's our kind of community version that is available for everyone to kind of try and use it. So you can test out things over there. As an enterprise, we support all three clouds right now: AWS, GCP, and Azure. So happy to work with you if you want to have an instance in one of the cloud environments, and we can deploy it for you there.
Great. Vandit Pandya asked, what is tag and tagging? Maybe you want to throw some light about tagging workflow.
Absolutely. So think about tags as if you use Gmail, the labels, right? Or if you're using AWS, for example, right? Like how you can tag your resources, right? As you configure a database, for example, you can tag with any arbitrary. So tags are basically any arbitrary key value pair. And the idea is to kind of organize your metadata through tags. So take, for example, if you have workflows that are responsible for doing certain business functions, you can take them, tag all the workflows with that particular tag. So it helps you in two ways. One, as I said, right, like it helps you kind of organize information through tags. This is very similar to how, for example, in Gmail, you can add labels to your email saying that this is an email specific to travel, this is an email for personal or work and things like that, and then it gets organized accordingly. That's one way. Second is tags also acts as a proxy for you to be able to configure role-based access control. So instead of having to now give permission on individual workflow, task, secret, all the metadata, which if you have a lot of them can become a very daunting task, you can just give permissions at the tag level, saying that no, everything that is tagged as this, you should have these permissions. So now you can add a tag to a workflow task and it automatically inherits all the permissions from that tag. And if you remove a tag, all the permissions are gone. So it just makes it really easy to manage the permissions as well.
Yeah, thanks, Viren. I think this is especially organizing, indexing, and RBAC access is great. Thanks for answering those, Viren. I think one, and I think maybe we can continue in this.
Yeah.
Pandit also asked, Orkes is hosted on which cloud environment?
We are hosted on all three cloud environments. So we, because Orkes is kind of in your development flow, we have it available in AWS, Azure, and GCP, all three of them.
Nice. Perfect.
Yeah.
So far, so many questions. And if we have more to present, over to you.
Yeah, these are,
right. Okay.
Yeah.
Cool. I think no further questions that I see. I will just wait for a minute in case we have any more questions. But thanks for answering this, Viren. Joseph, if you're here, really appreciate you guys actually throwing out some light on Conductor and Orkes updates. Thanks for taking out the time, and I really wanted to thank everybody who's joined and kind of stayed. I know it's pretty late in India. A lot of people I see who are joining from India. It's almost midnight, so thanks for being here. And early morning for US folks. Thanks for taking out the time. Thanks, Joseph, for being here. Thanks, Viren, Anup, Joe. Oh.
Yeah. Thanks for having me.
All right.
Thank you.
Perfect. I'll send just great. I think one appreciation that you guys can see in Q&A. It's like, I love to use in Azure. Can I please get in how to use it on Azure Cloud? Can you help me on getting in Azure Cloud? Yes. Yes, Pandit, we can definitely help you on how to get this used on Azure Cloud. We have a community to actually where you can ask these questions. A lot of other people who are using it on Azure can help you, or Viren or somebody from my team can actually sit with you and kind of help you start things from scratch. The videos that the recording that we have done for this meetup will be uploaded on our YouTube channel and also possibly on Netflix's engineering channel as well. So you guys can see it there. Please look forward to our newsletters that will also have a link to this recording. And thanks everybody for joining in. See you again for our next meetup. Thanks again for all the panelists as well. Take care. Bye-bye.